Thank you for joining me today. As it says on the screen, we're going to be talking about planes, cheese, and zero trust security, particularly one layer of cheese that I think is a bit underserved. Before we go into that, bit of scene setting, bit of a pop quiz, I guess, for this time in the morning. Is it morning? Still morning, yeah. Any guesses how frequently cyber attacks are happening right now? Every hour, 30 second. Every 37 seconds is the latest sort of report that people are willing to put numbers against. That's on cybersecurity events in 2023. Percentage of businesses affected? 60, I heard. 68, that was Sophos. That is definitely much higher. Probably guessed from the accent. I live in the UK. Just this last week, 3 of our major supermarket chains and their supply chains have been hacked. And I went to the shops last week and the shelves are empty. Um, there's literally like no food on some of the shelves because cyber attacks happening at the moment, which is great fun. And the average cost for data breach, this number is rocketed since this stat came out, so I'll spare you that. But around 5 million back in 2022, this number is increasing exponentially. So that's the world we're living in right now. The landscape today, if you've not read this book, I highly recommend it. This is How They Tell Me the World Ends. It is a terrifying read if you have anything to do with technology, but really lays out the challenges that we're facing. Attacks are getting more sophisticated, expanded attack surfaces across all of our technology stacks. There's remote. We're now kind of world of remote work is far more common. There's a whole new attack vector and vulnerabilities that come with that, and then insider threats are becoming more prevalent. If you saw the previous talk about supply chain attacks as well, it's a really interesting one, and that's an emerging threat. Have to talk about AI-powered attacks. There's literally people being put out of work in these ransomware shops because they essentially were the people on the end of the phone line when people phoned up to pay their ransom, and now being automated with an AI chatbot, believe it or not. Ransomware as a service and geopolitical cyber time. But what's all got to do with aviation safety? Well, really, both of these are complex systems with potentially catastrophic failures. So who am I? I'm Alex Olivier. I'm one of the co-founders of a cybersecurity company called CyberWise that do authorization. Touch upon that at the end. I'm a software engineer at heart, but sadly ended up in the world of product management a while ago. But started at Microsoft doing technical consulting stuff for major banks, but been doing mainly SaaS in various industries and verticals the last 10 years, but always very much focused on the data, DevOps, and infrastructure side of things. So the security architecture was something that I very much had remit on, and 4 and a bit years ago started an open source project called CyberWise, which I'll come to, and we've managed to build a kind of a business and a company around that. The other thing about me is I'm a bit of a hashtag AV geek or aviation geek, self-proclaimed. Part of this job, I have to travel way too much. And one of my favorite TV shows is this Air Crash Investigators. I don't know if anyone else has watched this, but it goes and into detail about how these horrific airplane crashes occur and what happens behind them. Very interesting if you're into both kind of engineering and disasters, I guess. I also don't recommend watching on an aeroplane. You get some funny looks. But one common theme that comes up with that is there's this guy called James Reason. He was a British psychologist, and he did a lot of work to help develop the processes, the SOPs, the models for how accident investigation and risk management works in aviation. There's a lot of engineering, but there's also a lot of psychology around how you sort of investigate an incident and what led up to an incident, and he kind of built a lot of these models. And the Swiss cheese model is one of his. And basically, simply enough, you have some sort of situation and you have a potential for a disaster at the other end. And the idea is you have to go and put systems and processes in place to capture and basically prevent that disaster from happening. So in the aviation world, you start off with like things like pilot training, make sure the aircraft's airworthiness is as it should be, make sure you have good SOPs in place when situations occur, automation control, situational awareness, human error, etc. Essentially what the Swiss cheese model says is each of these layers should protect. And with Swiss cheese, you have holes in, and if those layers align, you can actually go all the way through and get to the disaster scenario. But with more layers in place, you sort of block and there's more chances to capture and prevent those disasters from happening. One example of that is an aviation system called Triple Modular Redundancy, or TMR. and it's just one of the systems inside of a flight control computer. Where so you have various sensors, hundreds, thousands, if not more than that, across an aircraft, measuring wind speed, attack vector, position of your rudders, flaps, etc., etc., etc. All those sensor readings are sent into multiple computers. In a TMR system, a triple modular redundancy system, there's 3 separate, individual, isolated flight computers. Fun side fact for when you're having a drink with a friend: the data backbone of an aircraft is basically Ethernet. There's a AVNIC standard, but it's essentially Ethernet on underneath, which has full duplex packet switching, but you can have priority on those packets as well. So those 3 computers receive the 3 sensor readings in parallel. Those 3 computers then have to go make a decision. If that decision is agreed by at least 2 of them, then if there's a majority, so at least 2 of them, then the action is taken. If not, it's not. You might have heard of raft consensus as well, similar inklings there. But basically, it has to be a majority before any action is taken based on the data. The idea being, if one of the flight computers is not behaving or something's not quite right, the fact you have 3 separate decisions that need to be made, and at least 2 of them to be agreeing before action's taken, you should kind of prevent issues. And so, if we look at that model, those holes line up, and eventually you have a layer that stops any potential issue, and you avoid an air disaster, and hopefully there'll be much fewer episodes of air crash disasters. So what does this all actually mean for software applications, and what's kind of sort of my interest in it? So if we were to look at the same model for what we do as software builders and architects, we might have a first line of defense where we say, okay, we have a situation, we have some service needs to be protected, needs to be secure. The disaster in this case would be a breach, a hack, or compromised identity, let's say. So we're going to stick a firewall in front of it, and we're done. Don't do this. This is kind of what's referred to as perimeter security, where you just protect your services with some sort of like firewall, maybe the VPN to come in, and that's it. That doesn't work in this day and age, and Zero Trust kind of leads down this model. And essentially, this is what you're allowing. One small hole in the firewall, there's no other protection behind the scene, and you're in trouble. So Zero Trust is a set of principles, very much pushed by NIST as the Standards Institute, defining this. Basically, trust nothing, verify everything. No more perimeter security. You want to verify explicitly, and you want to lose least privileged access, and essentially assume breach. Assume that whatever's running in your system, or the network, or the environment your system is running, has been hacked. How would you go and build and protect against that? So if we could look at it again, you might have that firewall layer. You might then go and start doing things like network segregation. You then start looking at encryption, both in flight, in transit and at rest, and making sure that's consistent across the entire architecture. You start looking at things like workload identities. So now you don't just assume the servers can do anything. You give each of your services or each of your applications a unique identity, and you authorize around that identity. You have that authentication layer in place, very much coupled with the workload identity. So you have a system that services can, or our users authenticate against before they can do certain actions. And so what does this look like in the modern world? And excuse my very strained metaphor of cheese Kubernetes. You have those different layers, and you want to go and start building up. And if we were to take those layers and apply it to maybe specific technologies you could look at to go and put in place in the context of a Kubernetes cluster, what would that kind of look like? So the first one, your base infrastructure. These days and age, you might be using one of the hyperscalers, say AWS, that's giving you the base infrastructure, giving you things like the firewalls, security groups, etc. And then you have your cluster, Kubernetes obviously being the one that's most prevalent these days. On top of that, you want to start doing that kind of network segregation piece. So there's now things like service meshes, Istio, Linkerd being the most common ones, which allow you to define network policies of what can happen inside of that cluster, and allow you to lock things down further that way. On the workload identity piece, Spiffy and Spire, Spiffy is the standard, Spire is the implementation, is a mechanism to give trusted identities to your workloads. It's very Kubernetes native, but doesn't have to be. But essentially, each of your services can be given a X509 or a signed JOT as their workload identity, and there's a way you can verify the root and the trust of that identity and use that to make further authorization decisions around what that system could do. For your authentication piece, both for the services and your humans or non-human identities, OAuth 2 is kind of the standard that's now come along here. Keycloak is just one example of a CNCF IDP, which you can roll out and put in place, so you have a strong mechanism to do identity and management and the whole joiners, movers, leavers of your identity process. And then the other end of things, great, you got this nice stack, but how do you monitor and audit it? So there's now standard things like OpenTelemetry. You have things for standardizing log collection. You have Prometheus metrics, etc. Having these in place allows you to get that visibility across your stack. But there's this gap in here, and this is something that's kind of always bemused me a bit, maybe it was the right word, around you have all these services, you have these stacks, you have these layers, and you can, under the tome of never trust, always verify, really this only takes you up to verifying the identity. Once someone's been given a token, an authentication token, that token may be valid for like say 15, 20 minutes, an hour maybe. That in that space, that time, if someone managed to get one of those tokens, they could do some serious damage in your system. And so I've always said that there's a kind of missing layer to the stack that most people think about this, which is authorization, and this is what I've spent the last 4 odd years building out and working on. And authorization is the number one issue. So OWASP, hopefully some of you are familiar with this, they do their every 4 or 5 year report on the top 10 issues for web applications in this case, and broken access control is consistently near the top, and in the last report was the top. I think the next report actually comes out next month. I suspect it'll be near the top as well. But fundamentally, your access control model is broken. So someone with an identity was authorized to do something that they shouldn't be able to do. So they have a valid identity, their authentication is fine, but what they're doing inside of your system is broken, or the access they got inside of your system is broken. So authorization is the, I don't know what bad baby bell, do you have that here, of the Swiss cheese model. It is the bad cheese of the model. And so just to be clear, authentication and authorization are separate concerns with annoyingly similar names, and even more annoyingly are reduced to these sort of shorted forms in a lot of spaces. So authentication with an N is the process of challenging someone to provide a credential. They give you a credential, your system verifies that credential, go yes, you are authenticated, you are who you say you are. Authorization is the next step, which is okay, you are who you say you are, but are you allowed to do that particular action? Can you access this particular resource? Can you view that particular booking? Can you edit that particular expense? Can you create a new invoice? These are the business level access controls that you need inside of a system that you need to authorize inside of your applications. Side note: authorization is even confused in the HTTP spec. So there's many of you might be used to putting inside of your HTTP headers an authorization header with a bearer token. That's actually authentication because you're providing a credential. That really should be authentication, but that's besides the point. Meta point being, this gets muddled up a lot, and it's annoying and confusing, and there needs to be a better way to talk about it. So how does authorization actually become a problem? And I think the best way to look at this is if we go and pretend to scale up a company. So in the early days, so you're building out some software, you're building out some application, and you have what I call sort of the blissful days of roles, where you have your simple users, maybe there's you as the system builder, and then you have maybe an end user, and someone will log into your application, and you can go and put a simple if statement into your code. If the user's email contains your company domain, great, they're an admin, they can do everything. If they don't, then they're not allowed to do everything. You can maybe use an OAuth scope to do this as well, but it's a pretty binary, well, it is literally binary, whether someone can do actions or not. Very coarse grain. You essentially have like an admin role and a user role at this point. Very simple, and off you go. And this is something you could just throw very quickly into your application code inside of your request handler to check whether someone should be allowed to do an action or not. But if you scale up a bit, things are going well, you've taken that first version, you've taken that first prototype, and you want to go and scale it out. Maybe you've got like half a dozen features now, you're at the point where you've got like a sales team that are going to go and pitch this product to the world, and one of the first things that will usually come up is you go, well, we want to stop giving away all the features to everyone. We want to sort of change our product packaging. We want to slice and dice maybe how we give out features to users. Very common thing that I'm sure many of you have had to tackle potentially in building your software. So now you go back as a developer, you got that ticket. It's like, oh, okay, they want to have like a premium package and like a base package. And so everywhere inside your application code where you're checking whether users can do actions or not, you now need to go and extend that if statement a bit. So now not only do you need to check whether someone is an admin based on their company email, but you also need to check what package that particular company they belong to or subscription they have package level is. And so it's like, well, okay, it's not too bad. You can go and extend that if statement a bit. Potentially you start looking at an entitlement system or a feature flag system that can do this a bit more dynamically, but you still end up having to potentially extend the code like this. Let's go a bit further. This was something that really, really, really burnt me in one of my previous careers, where I was looking after kind of a big data platform. We had about 50 petabytes worth of clickstream data, and this was in the early 2010s. It was like 2014-ish. And at the time, there was a data sharing agreement between Europe and the US called the Safe Harbor Agreement. See a couple of nods. And all going great. As a European company, you could store data in the US and vice versa, and everything was all good. In the space of about a month, that was struck down. And so we're in a position now where we had to essentially go and segregate our data. We weren't allowed to store any data on our European customers in the US and vice versa. This was a real nightmare because not only did we have a lot of data, and we didn't necessarily have the best track of where it was stored and how. We had a very distributed architecture. It was doing streaming data processing. It was very redundant as well, so if our European data center went down, we were fine in the US and they could fail over to each other, etc. But now we had this legal barrier that got put in place. So besides having to figure out and filter down 50 petabytes worth of data and then reshore it to the right part of the world, depending on where they are, we then had to go and update all of our application code to firstly understand that there was that split between the different data types or the different data localities. And so now every user inside of our system had a region associated with them or a country associated with them. And every time we had to go and access data or check whether they could access data, we had to now do another check. So we had to go and look at what region that user is associated with. We had to figure out whether that user's current region, they were authorized to access the data in the region they were trying to access. And we had to go and further extend this authorization logic. So again, going back to a whole zero trust piece, we were fine at the firewall level, we were fine at the authentication level, we know who they are, we trust them, etc., etc. But on a per request or a per action basis inside the system, we had to go and add this logic, and we had to add in these architectural checks inside of the stack to make sure that a user was doing what they were meant to do. And so these checks had to go in, and we could have used further scopes like this. There's maybe libraries like Castle or CanCanGAN or things like this that you could bake into language-specific frameworks, but the model kind of required us to extend this access control check across the application architecture. So the next stage, things are going really well. You've built a product, you've scaled it out, you've repackaged it, you're in multiple regions of the world, and then you decide to go, right, let's go and start selling to enterprise in all the caveats that comes with that. And one of the big challenges that you face with this is you now have this kind of mismatch of organizational complexity. Because you as someone building the software, you probably aren't an enterprise business. You're not 20, 40, 50, 100,000 users. You're probably a smaller team. You don't really have that complexity in place. And this happened to me. So previous company, in the space of a month, we signed both Staples in the US and Emirates Airlines in UAE as customers. And we were a company of only 80 people at this point. And both of those companies came around to us and said, right, we have to onboard 60,000 employees about that to your system. And at the time, the IAM system, the role system we had inside our product, consisted of 3 roles: admin, manager, and viewer. And they were like, yeah, that's not going to work. We as an organization are set up to group and have hierarchies of users based on departments, teams, cost centers, regions, that kind of thing. And so you end up having to go back again to this access control logic and this authorization layer in your architecture and go, right, well, how do we go and do this? Do you have to go and start looking at all your application code again? You have to figure out where checks are made, and now you need to start potentially looking at what group membership someone has, or do you go out to AD and go and grab their memberships from there or some other federated identity? It gets quite complicated, it gets quite hairy, and you have to go and update all this authorization logic again in one place. And this code gets more and more complex. So you get through that, you've got some nice hierarchy, you've managed to enable your enterprise customers, and you're now starting to get more of these, and something that you might have to go through or might decide to go through is like, let's go and get our compliance sets. So ISO 27001, SOC 2 are kind of the most common ones, at least in the spaces that I've worked in, which basically you go through and jump through a load of hoops and fill out a load of paperwork and prove a load of processes to the auditors that demonstrates you are working in a compliant and proper manner as a business, and your applications, your architectures have the controls in place. And one of those controls that you need to have in there, or the processes you need to have in there, is around audit logs. So every time someone does some access inside the system, not just on your infrastructure level, but even on the applications you're building, you need to be able to not only have an audit log, but also prove that audit log is accurate to an auditor. And on a semi-regular basis, I used to get dragged to a dark conference room by an auditor, and I had to go and demonstrate our access control logic and our audit logs to them in order for us to renew our certificates. And the first time I did this, I was sitting there trying to like grep through logs in S3, and it really wasn't going well, and you could just hear the auditor sort of tutting at me. And we had to go and kind of rethink how this would work. And really, the point where these audit logs and this authorization logic and that layer in your zero trust architecture makes most sense is you can have audit logs all the way down that stack. So going back to that firewall, you can have the network request going through your firewall. You can see the traffic across your network through some of the service meshes. Your IDP, your authentication layer, will have the full authentication ceremony logged as well. But then down in your application layer, where you're doing the real action, the thing where you want to try to avoid that disaster scenario, things sometimes, or quite a lot of the times, get lost. And really, it's inside of that authorization logic where you're checking whether a particular user can do a particular action on a particular resource, should be allowed or not. And so, if you were to do this manually, you might have to go back to where we have that massive if-else statement, or getting more massive statement. So here now we're checking. Is that going to work actually? Yeah. So we're checking whether someone is in the company domain, so they're admin, cool, or they're in the right package. So we're doing the packaging example. Then we're going to check what group someone's in, so handling that kind of enterprise hierarchy type problem. Then we're doing the region check to make sure someone has access to the data in the right region based on all the data locality laws that you need to comply with. And then the actual action will happen. And before we do that, we're going to capture an audit log. So we're going to go right off to some, say, logging system. Let's say, cool, right, this action occurred, it passed all the checks, here's what the user actually did. And this is something that you just have to have in place if you're going to service a particular type of customer or you want to go and get those compliance certs. So if anyone's working in like insurance or finance or medical tech, which we have a lot of customers in, this is just a must-have. It's a non-negotiable, and you will get a lot of grief from procurement teams at these type of businesses and compliance teams at businesses unless you can prove this. So in terms of the actual implementation, you might go and look at maybe a logging library that's built into your particular framework of choice. You're going to send it off to some logging system somewhere, and maybe you're going to push it off to a SIM if you have one of those in place by this point of your growth. So at some point in this journey, not necessarily in this order, you may be reaching the inevitable discussion of architecture and, hey, we should go and do microservices, or maybe another time to rethink it. Not necessarily because it's the best thing out the gate, but maybe you're at your point now where you maybe have your main applications in, say, Node, you have some data science stuff going on in Python, you have maybe a legacy component written in Java, let's say, and you need to start thinking like, well, we have this authorization layer to fit our architecture, but it needs to work across everything. And you then run into a bit of a problem, because that logic, in theory, and most times in practice, that you've written in this case JavaScript, you now need to convert that and translate that into every other language under the sun that you're using. If you have one web service in Go, another one in Node, another one in Java, every time this authorization logic changes and that access control logic changes, you're going to have to get that ticket, firstly, find the right team that knows that particular language and get them to re-implement the logic. And you're going to end up with n number of implementations of this access control logic, which is fraught with issues, potential issues, let's say, particularly if the tests aren't rigorous or not being tested the exact same way. Hopefully your end-to-end tests will cover this. But you're now going to end up basically repeating work in n number of languages for what has to be and what should be standardized access control logic across your application. So you, again, never trusting, always verifying actions inside of the system. And so this new layer of cheese, the never trust, always verify, again by NIST, as part of their zero trust architecture, they put it out. They sort of designed this pattern of externalizing authorization logic out inside of the system. So if we go and look at architecturally, what would this be? We sort of know at this point someone's gone through all the different layers of cheese so far, and we know who they are based on the API call, the gateway, etc., etc. And we know what resource they're trying to access, and we know what action they're trying to do. So we need to essentially have this standardized thing, this authorization service, let's call it, where you can say, here's this user, they've got through the firewall, they've been authenticated, we know their identity, they're on the right network, blah, 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 blah. But now we're actually at like runtime or API call time or execution time. Can this user do this particular action on this particular resource? That request, that payload would go to this authorization system. This authorization system would have loaded it into policy. That policy would be a standardized way of defining your authorization requirements, sort of an as code approach, let's say. And that decision point would then evaluate that input against that policy and return back at its core basically whether that action should be allowed or denied. There's other variants on top of this, but the primary thing you're trying to figure out is, can this user do this action on this particular resource with this particular context? And so going back to James' reason and his work and like defining SOPs, the way to think about your authorization policy or your access control policy is like an SOP, a standard operating procedure. So spoilers, I guess. Cerbos is an open source policy decision point. We have a whole business around it as well, but everything I'm going to talk about now is completely open source. I'm not here to sell you anything. You can grab it off GitHub. What you see on the right hand side is a Cerbos authorization resource policy. And here we're actually looking at a way of defining a contact resource. So think of like a CRM. And then we have basically all the different rules that define all the different actions that a user can do upon that resource, and under which condition those actions should be allowed. So we could have what's probably not recommended for production, but we could have a wildcard rule that says if the user has a role, so your IDP has issued them a role of admin, then all actions should be allowed. Pretty binary, not great, but it allows you to do what's referred to as RBAC, role-based access control. But then when things get actually more relevant is where you have much more fine-grained or attribute-based control checks. So now we're saying that a user can read if any of these conditions match. And so we can check whether someone's in the sales team or their department is in marketing and a particular resource they're trying to access is active, let's say. And this gives you a way of defining your authorization logic as something that's versionable, testable, auditable, and more importantly, not inside your application code. So it means you don't have to know Java, you don't have to know Go, you don't have to know TypeScript or whatever to understand how your authorization logic works. This extracts it out into something that's a bit more human readable. It's still YAML, love it or hate it, in its current form. But it's something that is now an asset that you can actually go and audit, and going back to getting your compliance cert and going back to getting your SOC 2, etc., having these things to basically demonstrate in a way that isn't application code how that logic works is kind of a critical capability, and allows you to truly get to a model of actually zero trust architectures. So how does this actually look in practice? So you would have your user, they are accessing your application, probably going through some sort of API gateway. You could do sort of a medium-grained authorization at the gateway level, where you want to check whether this particular identity can even hit this particular route before it even lets it through the gateway. But ultimately, it'll end up down inside of your application layer. At this point, your application layer really knows two things. It knows the identity of the user, because the upstream to this is your IDP that's issued a token, let's say. And that can go off to maybe a directory to go and fetch further context about memberships, groups, those kind of things, and returns back to your application that token or that context. The second thing your application knows is what resource they're trying to access and kind of what action they're trying to do against it based on the request. So they're trying to view an invoice, they're trying to edit an expense, they're trying to download a report. And your application layer is the source of truth for what those assets are. So it can go off to its own database or services to go and retrieve that from the system. And then now, unlike before, rather than having that if-else case switch style logic all over the place, you just package up that information. Okay, here's the principal, here's the resource, here's the action. So the principal is the user's identity, or the API key's identity, or the service account's identity, or the workload's identity. It doesn't have to be a user or a human in that sense. Here's the resource they're trying to access, and here's the action or actions they're trying to do. That gets sent off in a request to that policy decision point. It could be Cerbos, but there's other projects out there. Open Policy Agent is the CNCF project if you're interested in alternatives. That policy decision point has loaded into policy. Now in our world, those policies could come from a database, it could come from a disk storage layer, it could come from a Git repo if you really want to follow the GitOps style workflow. And those policies get loaded into that policy decision point. So when that request of can this principal do this action to the resource comes in, the policy decision point will evaluate those policies. Before it does anything, it will create an audit log of the decision. So at this time, this principal will try to do this action on this resource, and it was allowed or denied by this particular version of this particular policy. And you can write that audit trail off to whatever you're using for your log collection. And then it returns back to the application. Typically either that allow or deny. So this action, view should be allowed, edit should be denied, etc., etc. Additionally, it can also return context for why a decision was allowed or denied. And also it can return what's called a query plan. So if you wanted to like pre-filter your database results based on what access the user has, you can actually interrogate a Cerbos PDP, a policy decision point, to get back essentially the where clause that is dynamic based on your policy to apply to your database query to pre-filter the data down, and thus locking down what access a user has to resources. Just one side point about implementations. This model, this pattern, I guess, is becoming quite dominant thanks to sidecars, which I know the tide is maybe turning a bit on sidecars and Kubernetes, but one of the things that many of you with architecture hats on may be worrying about is like, there's now another service in my call chain, because authorization is in the blocking part of every single request, and you don't necessarily want to go into your application and then bounce out to another service and back. And there's a trade-off to be made here. What we've seen is the advantages of being able to externalize and take a policy-based approach to authorization logic are kind of outweighed by a potential off-box or out-of-service call, but there's now architectural patterns like sidecars that allow you to actually run that as close to your application as possible inside the same pod, thus kind of guarantees it's not ever going to go off the node and those sort of things. There's other alternatives where you can actually run it in process, which we support as well. But this model is something that is now much more achievable thanks to the work of the orchestration layers that now exist. So we go back to our zero trust, trust nothing, verify everything model. Before, we would have had all this if-else logic spread across your application code, which works, a bit of a management nightmare, and it's super hard to audit as well when it comes to compliance. By externalizing it, all your application code is now reduced to essentially a single if statement, where you go and do the check and you get back that allow or deny. And it allows you to sprinkle this across your application architecture where it makes sense. So do it at the gateway, do it at the service mesh level. You don't now just have to authorize north-south traffic, you can actually authorize east-west traffic. So it's not just requests coming in down to your services, you can start authorizing calls between services as well, not just based on their long-lived identities, but based on the specific payloads of the specific requests that are making to specific services using this exact same policy framework, and really allowing you to authorize every single call, every single RPC, every single operation that happens inside of your architecture. And about 10 years ago, Google published their paper about Beyond Corp, which I'm sure some of you may have seen, where essentially the model is every single one of your services, in theory, you should be able to put on the internet and be absolutely fine. You shouldn't be hiding things behind firewalls. If you're authorizing properly and to this level of granularity, every single service should just be publicly accessible on the internet. But if you are properly authenticating and authorizing every single call, that's not going to be an issue. So many of Google's internal services actually have just like public domains. You just go and hit them, but you and I would never be able to actually access them because we haven't got a Google account, an actual Google employee account. Same model and same architecture that you can start moving towards. So there's advantages and challenges to this approach. So advantage, big one is like you give this logic is defined centrally for how the authorization layer of your stack works. It means your policies could evolve independently of your code, and you're very agnostic to any particular framework or technology you choose. So as your application architectures evolve, and maybe as more DevOps teams, you bring out this platform, it doesn't really matter what the application teams on top are building they can plug into this because it's more of a service-based model. And because these policies are assets, you can take a very GitOps friendly approach. You can have tests around these as well, and you get that consistent audit trail. But like I said, there's always a trade-off. There's another service you have to worry about in deploying, or your DevOps team have to worry about in deploying. There's a new DSL you may have to learn for policies, and there's a new component, the critical path. But bring it back to the Swiss cheese model. Every layer, as I said, I think there's solid solutions for out there in the world. The one that I believe is currently underutilized is this authorization piece, and hopefully you've got a bit of an idea of why authorization is so key and how you can actually go and implement it in a scalable manner and actually bring you to a model where every single layer of cheese is strong and monitored and controlled, and making sure you never go from that situation to that disaster scenario. And with that, take any questions. Cool, we have questions. Can the policy decision point also be implemented as a reverse proxy? For example, providing permissions via the header in enrichment. Yes, so every policy decision point, not just ours, but kind of any out there, is essentially a very simple API or an RPC where you say, here's the user, here's the action, here's the resource, and it gives you back the answer. You can then go and plug that into, say, Envoy or whatever your proxy of choice is to enrich context. The other point where you see kind of enrichment like that happening is actually calling out to a PDP during the token exchange ceremony in an OAuth 2 flow. So actually using policy to decide which scopes or claims go inside of a token. The idea when you're doing this properly is every single part of your, essentially everything of every single process in the request from the client application down to your backend. Every single decision made at one of those should be driven by policy, which are centrally versioned and managed. So doing it at the IDP level, do it at the ingress, do it at a reverse proxy type level. Putting a reverse proxy or putting a proxy in front of maybe an off-the-shelf or a commercial product that you have internally. So we have like a customer, for example, that puts Cerberus in a proxy in front of Grafana, so that can actually limit what users can do in Grafana to more granularity than they're able to natively with Grafana. So thinking about it's the right mindset of where can I put in authorization, a policy-based approach across every part of the stack. By central authorization code, you also we did that one. Oh, there we go. What are the known limitations of service that might lead to some decide against using it? So there's the architectural decision that needs to be made of whether externalizing something like this makes sense in your stack. I would say if you're running a big monolith and are happy with that, then potentially this isn't the right approach, using service or anything else. If you've done the work to set up your sort of proper domain-driven design within that monolith, then it is kind of seems maybe slightly excessive to have an external one on top. But I'd say that is one thing to consider. And the other one is making sure you have kind of the business rigorousness to agree on what the policies are. A lot of the time, the requirements we see get given to product or applications teams are just basically handed off to devs and say, yeah, I can implement these rules without really total agreement on the business side of things and what's going on. So getting externalized authorization right is really dependent on getting the whole business bought in on what those rules should be. Great. Is that it? Cool. Oh, there we go. How do you test the authorization spec? Do you have to write all tests yourself, or is there a built-in support for generating tests based on specs? There's tooling out there, but written both by us and other open source users, where you can basically start taking a forms-based approach for defining your policy, and with that, it will actually generate the tests for you as well. So it's almost like snapshots, where you can sort of set up what the rules need to be, and then it will basically generate the tests off the back of it. So as part of our onboarding, you give us a list of all your resources, all the actions, all the rules. It will not only will generate a policy for you, it will generate the tests for those also. And then speaking of tests, as well as those tests, we also have this whole CLI runners, etc. So you can, inside of your CI pipeline, control, actually run the tests before they go anywhere near sort of your production environments. Great. Does this support? Does this support source IP checking scenarios where the IP provides some level of authentication? If by that you mean basically checking the incoming IP address in your policy, absolutely yes. IP address is a great example of the kind of additional context that you could use inside of your policy to make a decision. So a classic example we have is a lot of our users will go and put a blanket rule in, which is if it's outside of office hours and the request is not coming from not coming from the office IP range, flag it and maybe deny access with various break glass scenarios as well. But yeah, the IP address is definitely one of the key bits of context you can use. Great. I think I'm out of time. Thank you very much, everyone. I'll be around if you want to chat.